Alright, hey guys, welcome to this session by Great Learning. My name is Anirudh Rao, and in this session, we're going to take a look at Python for machine learning. Now, ladies and gentlemen, Python is one of the world's top programming languages that we have, and machine learning is considered to be the future of all computing, right? Now, considering this, we're going to have a fantastic session where we're going to understand a lot of things with respect to how you guys can go on to learn and how you can use Python for machine learning as well. We're going to cover a good amount of theory, and definitely we're going to take a look at more than one algorithm in the hands-on session as well, right? Well, I hope you guys are excited as me to get started on this. Now, ladies and gentlemen, before we go ahead and get started, can you all head to the comment section and type in a yes or a no if you of course can hear me fine and if you can see my stream fine. So once you guys go on to give me a confirmation, we can go on to begin this session, right? Fantastic. Now, ladies and gentlemen, while you guys go on to give me a confirmation, I want to tell you that I'm monitoring all of your comments in real time on my mobile phone, right? So regardless of any questions that you might have with respect to Python, with respect to machine learning, or anything that is that you want your doubts cleared, please head to the comment section and definitely put them down in the live chat. I'll be more than happy to help you out, right? And guys, as always, let's keep this session highly energetic and with a lot of energy and of course enthusiasm to learn these concepts as you guys always do, right? Fantastic. Now I've got a couple of people saying yes. Arvind says yes, Swati says yes, Chandan, Dhruv, Sana, Himanshu. Fantastic, guys. All of you all have given me a confirmation. Now, before we go on to actually check the agenda for this particular session, let me quickly take a minute of your time to guide you about this fantastic venture we have here at Great Learning called as Great Learning Academy. Now, Great Learning Academy is a fantastic place, and I would recommend all of you all to take a look at this. Now, why do I say that? Well, Great Learning Academy is a place where over 1 million learners from 160 countries come together to actually learn new concepts and take away a lot of things across multiple domains, right? So here we provide over 300 plus courses, again completely free of cost, wherein you guys can sign up for free. You guys can take up any courses that you want for free, and as soon as you finish completing these courses, you will have a free certificate of completion as well, right, ladies and gentlemen? That is the fantastic part about Great Learning Academy here. Now you can find a lot of details. You can find details about the new courses that we have launched, all the popular ones. We have courses in English, we have courses in Hindi, and of course, right, since we are trying to put out the highest quality of courses, all of these courses are again taught by subject matter experts on the level of beginner courses, intermediate courses, and even advanced courses, ladies and gentlemen. But then, to talk to you quickly about the Great Learning Academy's, Great Learning's career path, you have to understand that with respect to any domain that you might pick, there's a very good chance that you will be trying for a designation, right? For example, as a person who's enthusiastic in machine learning, you can become a machine learning engineer, you can become an NLP scientist, or you can become a software engineer in the lines of AI and ML, right? Now, let me quickly click on this machine learning engineer path to guide you about what it is, right? See, as of now, you can see fantastic stats on your screen. We have somewhere around 18,000 jobs in India right now for machine learning engineers role. The average salary is fantastic. It's over 10 lakhs per annum, and of course, all of these whatever we're talking about, be it the courses, be it having an access to these salaries, you definitely have to take a look at some of the career transformation programs we have here, right? Now, ladies and gentlemen, we have multiple PG programs on the lines of AI and ML as well. Make sure you guys stick till the end of this session because there I'll be guiding you on how you guys can go on to become complete experts in machine learning, right? And of course, you can find out a lot of different things regarding people giving us their feedback, people telling us about what they think in terms of Great Learning Academy as well, right? Now, to get to the career transformation programs, ladies and gentlemen, I highly suggest you take a look at these free courses which will help you start your journey towards machine learning, towards becoming a machine learning engineer, right? We have again multiple different courses. As you can see, we are providing somewhere around 18 different courses that you guys can already start out with, get up to speed completely for free, right? You can take up all of these, right? We've put it in an order to make sure that you guys have a fantastic structured start to your learning, right? So you can finish all of these in course. In fact, let me click on the basics of machine learning. As you can see, somewhere around 26,000 other learners listeners have picked up this course. You can find out all the details about the course, the syllabus, and eventually, guys, as I told you, all of this is completely free, and you'll even get a certificate of completion that looks like this, right? Yes, again, to reiterate, ladies and gentlemen, this is all free, and you guys can opt in for any number of courses you want and complete them as well, right? And of course, there's many ways you guys can reach Great Learning Academy. I'm sure you guys know this by now. The most important way for you guys to take a look at would be greatlearning.in/academy, the easiest way. And of course, if you guys are tuning in from your mobile phones, we have people tuning in from their smart TVs, and of course, right, if you have any other device that you're using it from, we in fact have the Great Learning app available both on the Apple ecosystem as well as the Android ecosystem, right? So you can definitely pick up one of these and you can reach Great Learning Academy with ease, right? So guys, now I have a question for all of you all. Can you quickly head to the comment section and let me know how many of you all have enrolled for courses in Great Learning Academy, right? Quickly, let's just see how many of you all give me a reply on that, right? Fantastic. Now guys, while you go on to reply to that, I definitely want to tell you that do take a second to subscribe to the Great Learning YouTube channel, because once you subscribe, you have access to multiple high quality live sessions such as this, and of course the plethora of videos that we are publishing on the Great Learning channel, right? So do take a second, hit that subscribe button, because throughout this session I'll be talking about the benefits of it, and by the end of it you yourself will see the immense amount of benefits you guys can have access to if you do take a second to subscribe, right? Fantastic, guys. On that note, let's get started. Now, the first thing that we really have to talk about is to understand what we are going to cover in this session, right? Now, this session is going to be somewhere around 60 to 70 minutes, ladies and gentlemen, and we have to begin this session by first of all understanding what it is that we're learning, right? We're trying to understand Python and machine learning, and Python for machine learning, in fact. Now, if you read the title Python for machine learning, you might ask a question saying why has it supposed to be why is it supposed to be Python? Why can't we use Java for machine learning? Why can't I use C++ for machine learning, right? So we're gonna understand why you have to go on to learn Python for machine learning. Once you understand the why part of it, you guys will be very curious to understand all the skills that are required for Python machine learning, right? Now, these are some of the most important skills that you cannot learn from anywhere, or you cannot be taught. This comes with experience, and these are really important skills, right? So we're going to take a look at that. Once we go on to cover that, we'll also understand how you guys can get started with machine learning, right? Learning a bit of the concepts, understanding supervised learning, unsupervised learning, reinforcement learning, and everything. And once you have those basics ready, you guys will be ready to take a look at all of these code practically, right? Now, ladies and gentlemen, as I told you, at the end of the session, we can have a practical demonstration where we'll be using a single data set over two machine learning algorithms to showcase to you guys that having a common data set doesn't mean that every time you get a same result when you use multiple algorithms, right? So we're going to check that fantastic concept out practically as well, and of course a lot more in this session coming towards you, right, guys? Again, I welcome all of you all to this session. Do take a second to hit that subscribe button. It would mean a lot to us, and of course if you're liking everything you're seeing on the screen, do take a second to like the video as well. Right, now, ladies and gentlemen, the first thing that I want to talk to you about is to ask you if you knew this. First of all, I think it should not be of any doubt to you that Python is one of the world's most popular programming language in the today, right? There are many languages, and for a really long time Java was the top programming language, but then Python's popularity was like a graph which just went steadily up, and there was literally nothing that could slow Python's rise, right? But if you're asking a question saying, hey, now, Python, basically, whenever someone says Python, if they've never used Python, the most common way to think about it is like, hey, was this programming language named after the snake Python? No, the programming language was basically invented by this person called Guido van Rossum. He's a fantastic programmer. Now, what Guido did was, back in his day when he was actually creating Python, he was watching this TV show called as Monty's Flying Python Circus, right? Now, Monty's Python Circus basically is a comedy TV show. It's a very old comedy TV show, and the creator of Python, Guido, wanted to pay a tribute to it. Hence, he named it after the TV show and not after the snake, right? And to talk to you about TV shows in itself, we all watch TV shows. Guys, head to the comment section and let me know what TV shows you guys are watching, right? I think the latest one that's trending right now is on Amazon, and I think it's called Family Man, right? Let me know what all TV shows you're watching, because regardless of what all it is, be it on Netflix, Amazon Prime, or any of these streaming services, they use a ton of Python every day, right? If you can see the full circle right now, Python's creator named it after a TV show, and now all the TV shows have to use Python in one way or another to get the content out to us, right? How fantastic is that? And of course, talking on the lines of Python, if you say Python, you cannot have a sentence probably without saying data science, right? Because Python and data science are really closely linked. That's because Python offers a ton of features to handle the entire world of data science as well. And if you're talking about data science, we're talking about machine learning, this means only one thing, right? Of course, there's going to be thousands and thousands of jobs being created across the globe, and each of these jobs pays fantastic salaries, and it's a constant requirement everywhere around the world, right? Right now, if you open LinkedIn, Indeed.com, or any of your favorite job hunting sites and just type in machine learning there, you will find a lot of jobs, and you'll be surprised to find out that most of these jobs will want you to have expertise in Python, and they'll also be giving you an advantage where you can have access to these jobs if you are a fresher or if you have a low amount of experience, right? That's a fantastic thing. Now, coming on to the part where we're going to have to discuss about why you guys should learn Python, I think the first point on the agenda should go unsaid, guys. Because if you take a look at Python, it is purpose built to do certain tasks. Now let me tell you this, I have my phone here, I have my phone charger right next to me. Now the charger has a specific purpose, right? It is used to charge the mobile phone or anything that would take the same port or the same connection. Similarly, Python is a language wherein it finds multiple different domains like web development, gaming, data science, machine learning, and it is built in a way where it feels like it's meant to be for that language, right? You have a bolt and you have a nut, and when those two go together, you know that these two are meant to go together, like it should work in union. Similarly, Python is a programming language that has the capability to tackle an entire world such as data science and even machine learning as well. But then, more than saying that it is purpose built for this particular thing, let's actually get down to business and talk about Python. Because first of all, Python is a programming language that is built to scale, as in it is built for dynamism. Today, you're working on a very small program, maybe you're a beginner, you're working on a very small program, and after maybe 1 month, 2 months, 10 months, you're gonna have a lot more experience working with it. At that moment of time, it doesn't mean that Python will be more difficult to work with just because you're working on complex project. No, Python will remain easy to work with even though you're working on a very complex project. That is one of the magical reasons why Python is considered to handle a domain such as this, right? And of course, ladies and gentlemen, Python is open source. When I say open source, I mean that you really don't have to pay anyone to use Python, right? The creators of Python have completely made it free in a way where if anyone wants to learn Python, all they are going to need is a good amount of enthusiasm and interest, like all of you all, and you can get started with it right away, right? This is the advantage. This is in fact one of the advantages. We can literally go on and talk about hundreds of advantages, but as you can see, I'm trying to bring you the best of the best advantages to ensure that you guys understand why Python is so important for machine learning. Now, ladies and gentlemen, take a look at your screen. It says Python is a popular choice for machine learning, right? Now, why is that the case? Well, with respect to machine learning, you will be using a lot of algorithms, a lot of tools, techniques, and there's a ton of other things which would be, which would be a pain for you to manually implement. But with respect to Python, Python has libraries, frameworks, and a ton of things that will help you actually, go on to write your code faster, right? Python has so many huge libraries. If you're talking on the lines of machine learning, scikit-learn. For deep learning, we have TensorFlow, we have PyTorch, we have Keras, we have so many libraries that just make sure that we as programmers find it as easy as possible to write Python code, right? That's one important thing. The second thing is that it's a large community. Python is used by millions and millions of developers across the globe, and I'm hoping hoping that you guys are also going to be a part of these millions of developers across Python, right? Because the language offers a very easy to read syntax in a way where even a complete beginner who has never ever touched a programming language in his or her life can actually start out with Python and eventually become an expert in it, right? If you can read and write the English language, there is a very good chance you can be trained to actually write Python code, because it's all high level, it's very easy to read, and unlike other programming languages where it can get a little confusing, right? Think about languages like C or C++. Now, ladies and gentlemen, I am sure that you guys have learned C or C++, or you might have heard of these programming languages, even Java, right? The syntax there is pretty difficult. You have to be trained, you have to be a technical person to sort of know what it is that you're getting, and sometimes it won't make sense. For example, for a person who has never tried C++, if I ask you, hey, what is stdio, or if I ask you, hey, what is cin or what is cout, right, they will have no idea. But if I say, hey, if I have to display a message on the screen, do you think the print function can help me? Well, the print function talks about displaying something all the time, right? Well, of course, yes. See, it's as simple as that. Of course, I had to bring this example to a very basic extent, but you guys get the picture here, right? So it's not about understanding why Python for machine learning. That part has already been concreted via multiple research, thousands of applications and millions of developers. When people say machine learning, people say use Python, right? That has to be the trend right now. And for the next 5-10 years, ladies and gentlemen, I think the trend is going to remain the same. Understanding this is very important, because if you start today, there are many skills that you guys are going to need when you guys are going to learn Python, and when you guys are going to be performing machine learning, and when you guys are going to be having a ton of fun with Python, right? But then to get to that, there are some really important skills that you guys have to understand about. These are some of the skills, ladies and gentlemen, that these are the skills that are away from the books. This is not something that you can read somewhere and learn. This is something that should come to you on your own, in your own terms, right? Look at the first one. It says data-oriented approach. Now, ladies and gentlemen, take a second to think about this. If we are training a machine to learn something, we are going to have to give it some sort of data, right? When we learn, we use internet to learn, we use YouTube to learn, we have textbooks to learn, we have encyclopedias, we have so many things that we use to learn. But since you're providing the data to the machine learning algorithm, and you cannot give it a book and say use this, right? Of course you can. There's really intelligent AI systems today, but for our case, in the majority of machine learning use cases, it happens like that, right? You provide data and it understands. Now, what you would require knowledge in terms of is to handle data. There will be a large amount of data if you want your machine learning algorithm to perform well in many cases. There, you need to have the capability to not only store large amounts of data, but to pre-process it, clean it, work with it, and then eventually send it to the machine learning algorithm for it to learn, right? So this kind of an approach is required. Of course, you can be trained on how to clean the data, how to pre-process, how to avoid things like overfitting and underfitting and all of those technical terms, but knowing that you have to find a way through data, and understanding that data is like a treasure box hidden in the beach, right? You guys remember when we were kids, we used to watch those TV shows where on the beach there is a pirate and eventually they start digging and they find a huge treasure chest full of gold. Data is like that, but if you do not know where to dig, there is no point. You'll never find the treasure, right? That is why you need that first point there. And of course, to add on to it, we have the second point, which is out of the box thinking. Out of the box thinking is super important, right? In data science, or even in almost all the cases in the entire world that we have today, programming, non-programming, do you think there will only be one solution for all these problems that we have? Do you think there's only one way of how you can solve a problem in the entire world? Not really, right? If we have a problem, we have multiple different approaches that we can take to actually solve the problem. Now, this is something that you're going to have to require. This knowledge that says, hey, I have a problem. Now, let me try to attack the problem from multiple angles to find the most efficient solution that I can, right? This is a skill you guys have to have regardless, guys. This is a very important skill. Now, the third thing is logic building skills. Ladies and gentlemen, you head to the comment section right now and you tell me, which do you think is more important? Knowledge of just how to write Python code, or do you think logic, right? See, if anyone is trained, you can write Python code, right? For example, I am speaking in English. Tomorrow, if I want to learn German, I can learn German, right? So learning a programming language, the syntax is easier compared to you actually figuring out the logic of how to implement. Even if you cannot write Python code, but if you can solve a problem, that is going to be a fantastic skill that will help you, right? And the last one, of course, guys, as I told you, Python will not become more complex as and when your projects become more complex. It is you who has to have the capability to actually understand even small amounts of data to start with as a learner, and later large amounts of data, and understanding that you're gonna have to scale up slowly and things will get complex, but your understanding will also improve in a way where none of it will eventually feel too hard if you've put in good amount of effort and time to understand these concepts, right? Fantastic, guys. Yes, look at the comment section now. Everyone says that logic is very important, right? Logic is important. Of course, both are important, but if you spend time figuring out the logic, right? Think about it. If you have ever used the programming languages, how many times has it happened where you know how to write the program, you know the syntax, but there is a mistake in the logic, right? Maybe back in the school days or college days, when we thought programming might not be so important, we might have just mugged it up, or we might have just followed it procedurally but never understood how it worked in detail, right? That is the most important thing. That is the gap that we want to bridge today, to make sure that at the end of it, you will also know how to write fantastic syntax, and you will also know how to build superb logic. That is a skill that you guys need to work on. Right, guys? Fantastic. Now, let us discuss a section where we'll talk about machine learning, and we'll understand the 3 types of learning that we can go on to do with respect to this domain, right? But before we get to that, we have to understand what machine learning even is. I am sure all of you all who are watching this video already might know what machine learning is. But let me tell you this. It's a very simple task of us actually training a computer to cats, dogs, sometimes even fishes, right? So they listen to you, and you don't have to keep training them again and again and again every day. Similarly, if that was your computer, you would basically train it once and it would understand stuff and would keep doing it again and again without asking for your help, right? That is machine learning. We are basically making computers more like human beings, as in that they can learn on its own, they can work on their own and eventually help you a lot, right? There have been certain case studies where a machine learning algorithm has increased the efficiency by 10,000 times as per if you just compare it to doing that task manually, right? 10,000 times more efficient, right? Now, of course, this is not all the cases, but there have been multiple cases, and that is the reason why this domain keeps exploding and keeps getting popular with every single day, right? And then, of course, since we're talking about machine learning, before we actually go on to discuss the demo, I want to make sure that all of you all have a quick introduction to know what supervised learning is, unsupervised learning is, and and of course reinforcement learning, right? These are the 3 types of learning, how the machine learns, right? We have divided into 3 types, and now you will understand what are the differences between these types. Well, let's start with supervised learning. Pay attention to the name, supervised learning, right? Now it is very, very similar. If you guys have, maybe little sisters or little brothers, or maybe, when you were only younger, you would have your parent or a guardian or someone maybe sitting next to you while you study, right? Someone was supervising you while you did the task. Or whenever you were writing an examination, there was an invigilator who was supervising the class, right? Look at the word supervise. Supervise basically means to guide, basically means to handhold and help, right? Here, how are we going to help the machine learning algorithm this way? First of all, ladies and gentlemen, look at the 3 images that you see on your screen right now. We have flowers, we have dumbbells, and we have a picture of a car, right? Now, even if I was hiding these subtitles that are present below these particular images, don't you think you could guess? Can't you just look at this image and say, hey, these are flowers with a bit of stem, maybe these are weights, these are dumbbells, or you would say gym, and then you would look at this and you would say a car. For all of you car enthusiasts, you can tell even more detail. This one looks very similar to an Audi TT. It's orange in color. It's fantastic. It's a coupe. It's a sports car. Now I can tell all of these even without knowing what they are, on the screen. Why? Because from our childhoods we have been trained to understand what flowers look like, what dumbbells look like, what a car looks like, right? For all these years, the machine learning algorithm in our head, to give you a very simple idea about it, has trained continuously to know what all of these are. But then we know it, but our computer will not. When I say our computer in general, right? So as soon as I give it a picture of a flower, dumbbell and a car, it will be like, okay, what is this? I do not understand what you have given me, right? But with respect to supervised learning, as I told you, we need to help the algorithm a little. This is why we will actually go on to tell what it is, the image that it is seeing, right? I'll send it pictures of flowers, dumbbells and car, and I'm going to tell it, hey, this is what a car looks like. This is what a dumbbell looks like, this is what a flower looks like. Please learn about it, and the next time I show you pictures of other dumbbells, other cars and other flowers, you should have the capability to actually try to guess if you can figure it out, right? That is literally how supervised learning works, guys. You would have given the label along with the data, and you're going to use that training methodology to actually go on to understand what all can be done, right? But one thing you have to know about supervised learning is that supervised learning is divided into two. Well, first of all, let's talk about machine learning. We have machine learning here. Machine learning is divided into three parts: supervised learning, unsupervised learning, reinforcement learning. In that, we just spoke about supervised learning. In supervised learning, we have two more divisions, basically with respect to regression and classification. Regression is used when we want to go, when we want to use a feature set and we want to analyze a particular variable, right? A very good example of regression is basically us trying to predict the future using the past data, right? Now you might have seen, you might have also used regression. If you open up Siri or Google Assistant on your phone right now and say, hey Google, what's the weather like tomorrow? Now that I've said hey Google, some of your phones might actually wake up and detect hey Google recognition, right? So it will basically tell you what the weather is tomorrow. Tomorrow is not even here yet. The clouds that are supposed to be here tomorrow are not even here yet. They're probably on the other end of the country right now. So how does Google know what the weather is going to be tomorrow, right? To understand that, you're going to have to use past values, analyze it, train a machine, and eventually go there, right? That is a fantastic example of regression. Now to talk about classification, guys, even a 3-year-old kid, in fact a 2-year-old kid can do classification, right? If I give you 2 apples and if I give you 2 oranges, let me mix it up and I give you, right, 2 apples, 2 oranges. If I give it to you, if I ask the kid to say, hey kid, can you please put all the apples to the left and keep all the apples to the right, or just say that, just try to give the kid the apple and the orange, what it will do? It might also eat the apple and eat the orange, but the point is it will have the understanding to know that, hey, these are 2 different things and I have to keep it aside, right? That again is another good example of how classification works. Regression and classification are very, very important parts of supervised learning. That's fantastic. Supervised learning is what we use to train as well, but what is unsupervised learning? Unsupervised learning doesn't mean that we just give the data out to the machine learning algorithm and say, hey, you do whatever you want, you learn on your own. That is exactly what we are going to do here, right? Here, the goal is to not train the machine on images and get it to detect other images. What we're trying to do here is we're asking the machine learning algorithm to find a structure hidden in the data. If I show it the picture of a car, it will know that a car will have a windshield, it will have a couple of tires, it will have a couple of rims and all of that. So it uses all of these tiny details to learn what a car looks like on its own. It doesn't know that it's a car, but if it sees other images similar to this one, it can say, hey, I know what this is. I have learned something similar to this, right? That is unsupervised learning. As you can see at the bottom, I have not written that this is flowers, and I have not written that this is a dumbbell, and I have not written that this is a car. But yet, once it's trained, it will have the capability to know what a car looks like, to understand the structure that is used when you talk about a car, right? Of course, this is not the only picture of the car in the entire world. You can have multiple angles. You can look at it from the roof, from the front, from the side. You can like do everything like you would pose for maybe an Instagram photo or something, and still it would know what a car looks like. if your unsupervised learning algorithm works really well, that would be a very powerful implementation of machine learning, right? And of course, since we're talking about unsupervised learning, we also have to take a second to discuss the grouping that we have here. Ladies and gentlemen, just like how we had regression and classification for supervised learning, in unsupervised learning, we have clustering and association. Clustering is very similar to classification, right? If I give you three orange colored balls, three blue colored balls, and maybe three pink colored balls. I've given you three different types of, maybe those squeezy balls, right? So if I just gave you them and if I said, hey guys, everything is in a basket, can you please arrange them, right? Or maybe consider it as three dolls. If I say arrange it, can't you think you guys can arrange it in a different way based on the color, based on the size or something, right? You can do it because you're trained. When we get our machine learning algorithm to do it, it's called clustering and unsupervised learning, right? And then of course we have association. Again, I promise you that you have used products that are that already use association, right? If you've ever shopped on Amazon, or if you've ever shopped on Flipkart, or even watched a TV show on Netflix, it will tell you after you're finished watching a TV show or a movie, it will start recommending the next one, right? It will say people who have watched this movie have also watched this. Or once you're buying something on Amazon, if you add it to the cart and if you scroll it down, there will be multiple options where you will also find other items that will be added in your cart, right? If you can choose the option. For example, if you buy a new mobile phone, we know that if you buy a mobile phone, we need to probably put a tempered glass on it, or we need to put a case on it, right? So Amazon will already know this. It will tell you like, hey, people who have bought mobile phones before have also bought tempered glass. So do you want to buy one? Right? How does it know? Of course, there could be one human saying for everyone that buys a mobile phone, just suggest a tempered glass. But I'm very sure it's not a manual task. It's a very important machine learning algorithm that is working in the back end. And in fact, Amazon gets somewhere around, I think 35 or somewhere around 36% of their sales just from these associations, just from suggesting people, hey, do you want to buy this? And 30% of Amazon is how much? Ladies and gentlemen, the amount of money, the amount of transactions that happen on Amazon, if you take the 30% of it, that is in billions of dollars, right? Billions, not million, it's a billion with a B, right? That is a good example. Now we understood supervised, we understood unsupervised. Ladies and gentlemen, let's quickly talk about reinforcement learning. Reinforcement learning is something super fun because you would have used this again. Ladies and gentlemen, head to the comment section right now and can you guys tell me if you have ever had a pet dog or a pet cat, right? You can have other pets also, but if you have had a cat or a dog, this example will work well. In fact, it will work well better for a dog than a cat, because with this experiment, the cat might just scratch you and run away, right? I don't think dogs do that. So to talk to you about what reinforcement learning is, this is basically feedback based learning. As in, once you learn one step in the process, right? So let's just say the solution is 10 steps. Once you learn the first step, you will try to assess if you're getting closer to the solution or if you're getting further away from the solution, right? Just like that, in multiple steps, you will get closer to the solution, and eventually you will be at the solution. Now, how is this related to your dog or your cat? Well, the algorithms, the reinforcement learning algorithms work basically on a way of how it can increase its rewards every single time. Now, have you ever had your pet trained to give handshakes? Have you ever had your dog trained to maybe sit in one place, roll over, do all those tricks, right? How do you think it does that? How do you think it was trained to do that, right? If you ever look at a dog trainer, he or she will actually instruct the dog to do something. And as soon as the dog does that, he or she will basically give the dog a little treat. They'll give it a little sweet. They'll give it a little biscuit. They'll give it something for the dog to eat and become happy, right? So the dog knows, hey, I have to work. If I do this, if I give a handshake, I'll get a biscuit. So the dogs are like super excited. And of course, even if your dog is fully fed, the second you pull out a biscuit, the dog wants the biscuit. That is it, right? So literally that machine learning algorithms also work in a similar way, where they will always want to work towards the rewards. It will know if I work towards this, I'll get a reward. So let me see how maximum rewards I can get. But if you're training your dog and you ask for a handshake, but the dog is like, nope, sorry, and it runs away, do you think it will still get the biscuit? No, right? Of course, it's not getting the biscuit. That's the reason with respect to reinforcement learning. Every time you point the algorithm in a way where it just works towards the solution and it has a mindset to just get the maximum rewards possible. Once it goes on to maximizing these rewards, it is a very intelligent algorithm, just like how your dogs are all very intelligent, right? That, ladies and gentlemen, is reinforcement learning, right? Now, we have had somewhere around 35 minutes of good amount of understanding of theory with respect to why Python, understanding a lot about Python itself, knowing a bit about machine learning, taking a look at all the algorithms on the lines of supervised learning, unsupervised learning, reinforcement learnings. And guys, if you're a person who has had cats, I don't know if you really should try the biscuit example, because I remember telling this to someone and they told me it didn't go well because their cat never listened to them. The cat just meowed and ran away, right? So it really doesn't care. I have nothing against cats, I love cats, but that is the thing. If you have a dog, you can try it out, and every time you try to train your dog, know that your dog is using reinforcement learning to learn, right? How cool is that? Alright guys, on that note, let me just quickly get a gulp of water and we can go on to actually practically check out two algorithms, right? And let me also see what comments you guys have put down here. Okay, the person called Arvind has been asking one question. Arvind, please don't spam the particular question. I've seen your question. You ask what is overfitting and what is underfitting, right? Now, ladies and gentlemen, overfitting is a concept where your machine learning algorithm looks so much deep into the data that it doesn't understand what it is seeing. It will only be seeing noise and useless stuff rather than it can use to learn something, right? Now, to give you an example of overfitting, let's just take the same example where you're on the beach and you want to dig for the treasure, right? What if you just miss the treasure and you're continuously digging and you find nothing, right? You only find mud or you only find sand. That literally is overfitting. If you do not know where to look, first of all, and second of all, even if you know where to look but you don't know how much of effort or how much of digging needs to be done, then it is overfitting. And there's another case which is underfitting. Underfitting is when your machine learning algorithm doesn't know, it doesn't explore your data enough in a way where it doesn't learn anything at all, right? Underfitting, if you have to talk about the same beach and treasure example, it is when you just dig maybe 1 or 2 feet, right? Maybe you dig for half an hour or 1 hour and you get tired and you're like, hey, there's no treasure here, let me just go. That is literally underfitting, right? It doesn't put in so much effort that it's seeing something that it can understand. I hope this answers your question. Right? Okay guys, I'm going to pick up your questions, but let's quickly take a look at the practical implementation. Now these examples that we're going to be taking a look at, basically we'll be taking a look at two important case studies with respect to two algorithms. We're going to take up linear regression first, and we're going to take up another algorithm called as the KNN algorithm. At first, let's start with linear regression. Now, regression is something that we already discussed, right? Regression is when you use a value to try to see if you can predict another value based around that, or if you can use a bunch of values to predict something in the future. Just like the example where I told you how you can predict tomorrow's weather, right? That is regression. Now, one question you might ask saying, hey, if it's just about finding tomorrow's weather, why is regression so popular? Because if you're looking for machine learning jobs, linear regression is the first question that might come up on the interview, right? Well, let me tell you this, linear regression is super popular because this is a type of learning wherein of course it's all supervised learning, wherein you're basically trying to understand the cause and effect relationship between variables. Let's talk about the example that we are about to discuss right now. In this linear regression model, what we're trying to do is we're trying to understand why a house costs so much, right? A house. So if I have to buy a new house here in Bangalore, I'm going to do so much research, right? I'm going to find out which area it is in. I want to know the crime rate in the area. I want to know how many floors. I want to know how many cars I can park. I want to understand so many things about that property, right? And if it's a very tiny house and someone is just quoting a meaningless amount to it, I'm like, what? It doesn't make sense. So I need to know what are these features that will eventually have a say in understanding how the house is priced, right? For For example, we have multiple areas in Bangalore wherein the house prices there are extremely expensive because there's ultra luxury, ultra modern houses. Similarly, I'm sure it's everywhere or in most of the metropolitan cities in India, right? So here we're going to consider one example similarly, but the house details are all present in the USA, right? I'm very sure you guys must have heard of Boston. So we're going to take a look at a Boston housing data set where we have details about multiple different houses. Now what we need to do is we need to use this data to see if our machine learning algorithm can predict the price of that house just by looking at data, right? Let's head to Google Colab, which is basically my Jupyter notebook, and we can get started, ladies and gentlemen. Now let me quickly close this, and ladies and gentlemen, I hope that you guys can see my screen right now. It is the part where we are going to discuss the demo for linear regression, right? This is nothing but Google Collaboratory. Google Collaboratory is a very simple Jupyter notebook that is a part of the Google products, right? The Google ecosystem. This will work just like Jupyter notebook. This will work like any other Python toolkit or Python GUI that you guys are going to use to execute, right? You just have to type the code, hit enter, and your code is executed. You don't have to install anything. You don't have to worry about anything, right? Well, let me zoom in so that people who are watching from your mobile phones can also have a complete understanding, right? Of course, we know that a lot of you all will be watching this from your mobile phones. So let me zoom in so you guys can see this better. Now, as I told you, we're going to be using linear regression, but the first thing we need to do is we need to bring in our data set to use, right? But even before we talk about data set, look at this. We are importing three libraries, NumPy, Pandas, and scikit-learn. NumPy and Pandas are used for data handling with respect to Python. In fact, NumPy actually stands for numerical Python. For any sort of numerical operations, you would go on to use NumPy. And of course, sklearn, the third one, or scikit-learn as it's called, is the machine learning library for Python, right? Now, as soon as I run this, I'll actually get an error. The error says, hey, where is the data set? I cannot find this data set that you're telling me about. That is because I'm executing this online, but the data set is in my computer, right? Now, let me quickly go on to upload the data set. It's basically in my computer. Now, let me open data set. Let me open the housing data set, right? As soon as I click on it, the data set is now uploaded. We're going to be using the same data set for both the examples as well. Okay. Now you remember there was this error. Let me run this again, and this time there is going to be no errors, and this time I have the output of what the data looks like. Now, as soon as you look at this, you might be very confused saying, hey, what is this that I'm seeing? This doesn't look anything like details of a house, right? Well, let me tell you. You can see this heading that says CRIM. It's basically talking about the crime rate in the area. Of course, if there is a ton of crime in the area, all the houses there will have a lower value because no one will want to buy a house in an area which is like full of crime, right? No one would want to do that. And if you're taking a look at all the other things, for example, age of the house, of course, why would you want to pay a lot of money for a house which is like 45 or 50 years old, right? So here you can see that we also have details about the house. You have details about the there's so many things that you can understand here, guys. The amount of tax that is paid on the house, the amount of details with respect to how far away it is from the nearby supermarkets, how far away is it from the school, how many cars can you park in that particular house, what is the square footing in that house. You can have a ton of different details, right? Now this is what our data set is providing for us. This is us importing the data set. The next step is to pre-process the data set in a way. Now what I mean by pre-processing basically is to find out values which are not supposed to be there. For example, if I ask you what is the age of this particular house, you can see that it's correctly written that this house is 65.2 years old. But instead of this, if I ask you what is the age of the house and someone by mistake has entered their mobile number in here, right? Or they've entered their name instead of age. It happens, right? It happens in a huge data set. Now I've just printed out the first 10 rows for you. The data set is way larger than that. So what we're trying to do in this step is to understand if we have any of those values which will hurt the machine learning algorithm. It will train it incorrectly. So we have to remove all of that. But thankfully in my data set, you can see that whenever we try to sum all of these and find them, it says 0 everywhere. It means that my data set is already clean and ready to go. right? The next step, ladies and gentlemen, is very simple. Since we are training a machine learning algorithm, we're going to have to split the data into two: training data and testing data. This is literally like you using your textbook to learn in college, and later you'll go to the college to write your examination, right? That is exactly what we're doing. We're taking the entire data, we're breaking it into 70% and 30%. 70%, I'll just give it to the machine learning algorithm as is. It will see the data, it understands it, and it learns using that 70% of data. And later, the 30% of the data, I would have kept it hidden, and I will just send it to the algorithm to say, hey, I know you used the 70% data to learn, but here is the data that you have never ever seen before. Can you guess what this is? If your algorithm can guess that data the second time, the 30% of the data that you've hidden from it, it means that your machine learning algorithm has learned something, has understood something, right? But then if you just provide 100% of data at the start itself, of course it will learn using 100% of the data, but later whenever you ask, whenever you want to test your algorithm, it will always get it correctly, because it is literally, it is like you guys going to college, using your textbook to learn, and eventually keeping that textbook right next to you in the examination hall and looking at the textbook and writing. There is no point there, right? Similarly, that's the reason we have to split it out to make sure. You remember how college kids will always be complaining, saying we got a lot of out of syllabus questions? Think of this like an out of syllabus question us giving to the machine learning algorithm, right guys? Fantastic. And you can see all of these are like 3-4 simple lines of code, right? My point here is to not tell you what each and every single line means. My point here is to show you guys how easy it is to use Python for machine learning, right? Now the next step is basically where this is the process. These 3 lines of code that you see written in black, of course all the ones in green are comments. These 3 lines are responsible for training your entire machine learning algorithm. We're using linear regression. Eventually we're giving all the training data, the 70% data is going for the machine learning algorithm to learn, and as soon as this line is executed, your machine learning algorithm has learnt it. But it has learnt it correct, but I have to give it an examination, right? This is where this line comes in, where I'm giving it the testing data to say, hey, okay, you have learned something, but let me see what it is that you have learned, just like what your teachers would do, right? As soon as I hit run on this, with just 3 lines of code, the entire linear regression algorithm has learnt it, and now even it has come to a point where it has also understood how well it has learned. You have given the examination to your teacher has also corrected it, and they're ready to give you the result back. All in 3 lines of Python code, right? Fantastic. Now take a look at the next step, which is model evaluation. Model evaluation is us finding out how well the model performed. For example, here it says, hey, the error for linear regression is somewhere around 5.54. Fantastic. Now the error rate, right? Ladies and gentlemen, this is a very simple question I'll ask you. If there is something, if I tell you, hey, the error rate is this much, do you think it is good to have more error or less error? Of course, less error, right? So the error rate for this algorithm, this particular data, is 5.54. Let us just remember this. Of course, there are so many things that you can find out about this. There's something called mean squared error, right? There is a lot of technicalities to this number, but I understand that some of you all might not be trained machine learning experts. So instead of just catering to you guys, we'll have a lot of people watching this video. In fact, 161 people of you are watching this video, right? So let's just remember this number 5.54 for now. Let's quickly go back to the presentation and discuss about the next algorithm, which is the KNN algorithm. Now, KNN algorithm is an algorithm which is super fun to work with, because here it stands for K nearest neighbor. We are trying to find who the nearest neighbor is to us. Similarly, our data will find who the nearest neighbor it is, and it will understand what is going on, right? Now, if you if you go to a hospital and if you probably look around, majority of what do you find? You would find a lot of patients, you would find a lot of nurses, you would find a lot of doctors. Now, if you would go to Facebook's headquarters, you'll find a lot of application developers, software developers, AI experts, machine learning experts, marketing managers, and all of that, right? So these are the neighbors. If you're there, you will know who you are surrounded with. Now, right now, even you would be surrounded by people and you would know who you're surrounded with. That is the reason we are trying to build a relationship, build a structure with respect to our data, knowing by understanding who our neighbors are. Right now, let me give you a simple example to understand what it is that we want to do. Now, let's just say I want to build a classifier wherein I want to find out if the person is a male or a female just by knowing their height and weight. Now, I will not know if the person is a male or a female. All I will know is their height or is their weight. For example, I'll tell you, hey, the height of this person is 5'10", 5 foot 10 inches. The weight of this person is maybe 60 kgs. Now you have to guess if that person is a male or a female, right? You have to predict and you have to do it correctly. You cannot just guess and say, oh, it might be male. If not, it will be female. No, that's not how it's done. With respect to the data, look at this. Our KNN classifier will have data in height. It will have data in weight. And of course, we will know the actual answer to it, whether this person is a male or this person is a female or anything. This last column is not known by our algorithm, right? So let's take height, let's take weight, and let's put it in a graph. As soon as I put the height and weight in a graph, you can see that all these pink triangles that you see, these are the females. All the round green circles that you see, the spheres, these are the males. Now what I will do is, right now we have 7 people's details. I want to add another 8th person here, and the 8th person has height 190 and weight 110 kgs. Let me just put it on the graph, and as soon as I put it on the graph, this new entry that we added, it is basically this blue square that you see. Right now, take a look at this, ladies and gentlemen, on the graph. We are not going to talk about machine learning for a second. Can you look at it and can you say if that blue color square belongs to the classes of males, or do you think that blue color is a person who might be a female? In the majority, as soon as you look at it and analyze the neighbors, what do you think is your answer? Of course, it is very closer to the average details of the males, right? It might be a male. But with respect to our machine learning algorithm, since the name says k nearest neighbor, KNN, that k is actually a value. If I say k equal to 3, all I'm trying to do is I'm trying to find the 3 nearest neighbors for me. Right now, I am the new guy here. I am the blue guy. I'm sitting here. I want to find out who my nearest neighbors are. But how many neighbors should I find? I have to find 3 neighbors. So as you can see, as soon as I find the shortest path from 3 neighbors, all those 3 people are guys, right? Of course. So at this moment, you can 100% say that the new person you have added just by looking at their height and weight is a male. Right now, maybe let's take k equal to 5. Now I want to analyze 5 neighbors, but there are only 4 guys, right? So that's the reason you can see one more line that is coming in from our female, because this person is the nearest neighbor as well. But if you look at this again, majority, where is the data coming from? Who is the neighbor? Is it males or is it females in the majority? Well, it's males, right? So at this moment of time, just by plotting the graph, you can say, hey, that detail, that person is a male or a female. And we discussed k equal to 3, we discussed k equal to 5, but why are we only taking odd numbers? Why can't we take k equal to 2, k equal to 10? Well, you can actually take it, but in our particular case, wherever we are trying to do a binary classification with 2 classes, right? We have only 2 classes we are discussing here, male, female, nothing else for this example. So whenever you only have 2 classes such as this, you're going to have to take the k value to be an odd number, because that is how the KNN algorithm technically works. And of course, we can dive right into the details of it, right? Okay. Now, ladies and gentlemen, let's quickly take a look at this particular algorithm that we discussed, KNN, right? Let me minimize linear regression. Let me open KNN. Let me tell you this. All of the steps apart from last 1 or 2 steps are exactly the same as what we did before. For example, this line is exactly what we did in linear regression, so I'm going to run it, right? Fantastic. Now we have the data set. The next line is also the exact same one, wherein we tried to see if we have any junk values or any NaN values which we might have to remove. I saw this exactly as the last one. Now here is the next part where we try to take the data and split it out into training and testing. Again, exactly the same thing as we did previously, not one line of change. Literally word to word, it is the same thing as linear regression. But here is where we go on to use this one, guys, KNN algorithm. Look at these 3 lines. You remember the 3 lines we used for linear regression? Well, here we're going to be basically using the KNN regressor and we're going to be passing the value k equal to 3. You can see that 3 in the value. Let me zoom in a little more. Right, you can see that bracket value 3, right? This is the k value. As soon as I do this, I am calling the regressor. I'm telling, hey, I want to use KNN algorithm. The next line says, okay, you want to use KNN algorithm, but give me the data to train. well, the data to train is given. This process is called as model fitting. And once the model has learned it, what is the next thing? Giving an examination to the college. That is you trying to make predictions on your algorithm by passing the testing data instead of the training data. It is just 3 lines of code that differs linear regression and KNN. As soon as I go on to run this, our algorithm is now trained. It is trained using KNN algorithm. But the question you guys must be asking me right now in the comment section is saying, well, okay, so if we are only using k equal to 3, how will I know that k equal to 3 is the correct answer? Maybe I will get better efficiency if k is equal to 10, right? Now to answer your question, what I have done is I have taken k equal to 1 all the way to k equal to 49 and I have trained the algorithm just now 50 times from 1 to 49, and here you can see all the error rates for those particular k values. Now if I have to find the most efficient way, what do? I just find the error rate which is the lowest, right? Now initially I said k equal to 3. I am guessing that k equal to 3 will have the lowest values, but look at this, at k equal to 4 is the lowest error value, right? This is the lowest number in the entire graph because it just keeps increasing, but this number is efficient. So what it is trying to tell us is, for the Boston housing data set, if you train a KNN algorithm with respect to 4 neighbors understanding, it will give you the lowest error, right? Now let me scroll down and print the error rate once again for you guys. Now here we're going to be using k equal to 3. It's okay, k equal to 3, k equal to 4 doesn't make a difference. I'll tell you why. Here the error rate is 7.014. Do you guys remember the error rate that we had for linear regression? Don't you think it was 5.54? Let me scroll down. Look at this, it was 5.54 for linear regression, this exact same data set, but for KNN algorithm it is slightly higher. Now if I give you, if I ask you a question saying, hey guys, now that we know that error has to be the lowest, I give you 2 algorithms, one is linear regression, one more is KNN. Which has the lowest error? Linear regression, of course. Which are you going to use? Well, I told you to use the one where the error can be the lowest, right? Of course. So you can see that even if you just provide the same exact data to different algorithms, the way it learns, the way it reciprocates with respect to your data is going to be a lot different, right? So guys, this was the point of this demonstration, to showcase that in fact the output looks a lot bigger than the input, right? Now you can get this entire line of code with respect to just again one simple line. Let me just split this out and print this again to just showcase to you guys, right? Now let me add another code element and I'm going to paste this. See this, as soon as I just print one line, it is not even 10 characters. As soon as I print it, look at the output looks so huge, right? One tip for you guys is that with respect to machine learning and with respect to Python, you writing your code will be a lot less rather than the output. The output is going to be huge, but your effort into making that output huge, very tiny, right? That is again another fantastic reason of why Python is used for machine learning. But instead of telling you guys that at the start itself, I wanted to make sure you guys saw this firsthand. You saw the entire process of machine learning happen in 3 lines, right? Basically, model establishment, model fitting, model verification. Done. You might have thought, whenever I usually give conferences or speak about machine learning in public, people ask me saying, hey, do we have to write thousands of lines of code to do something simple? Do you think we wrote thousands of lines of code to do something simple here? No, in fact, we wrote probably somewhere around 20-25 lines of code to do something very, very, very complex. Right? That is the magic of machine learning, ladies and gentlemen. Now, to quickly talk to you about how you guys can learn further, I definitely suggest you guys to not be overwhelmed by the amount of content that is out there. Because right now, if you head to Google and if you just type in learn machine learning, you're going to find thousands and thousands, if not millions of websites which will basically teach you how to learn. But what many of these websites might miss is a structured approach, right? Imagine that you are, in your boat and you're crossing in the middle of the ocean. Now, if something happens to your boat, you fall into the water, and there's a very good chance that you cannot swim an entire ocean, right? It's not a swimming pool, it's the ocean. So if I have to talk about the same in our context right now, if you start learning from multiple places, or if you start learning from a place where there might be no structure in learning, it is like you in the middle of the ocean without any life raft and you have to continuously swim. Or if you don't, good things don't happen, right? So, with respect to your learning also, when you're learning something, it's highly suggested to always learn by having a structured learning path, just like how we do here at Great Learning, right? Every single one of the videos from every single one of the subject matter experts here at Great Learning will have good amount of structure so that you guys can learn fantastically well. And it is not only that, ladies and gentlemen, we take your learning and we align it with respect to what is required in the industry, right? There are so many cases where someone graduates from the college, they have a computer science degree, they have a technical degree, but to get a job they need to do something extra, they need to learn something which they have never been taught in college. Have you ever come across these cases, right? So we here at Great Learning are providing super high quality content, be it on YouTube, be it on Great Learning Academy, and of course with respect to all our college programs where we are tied up with universities like Stanford and University of Texas at Austin, right? And of course more as well. Now when this is the case, that's the reason I keep telling you guys to actually subscribe to the Great Learning YouTube channel. It's not because we want to increase our subscribers, it is to make sure that you guys have access to these learning materials whenever, as soon as we go live. For example, we are having a live session right now, and I am seeing that a lot of you all in the comment section have have fantastic approaches. You guys are asking questions, you're answering questions. I am sure you guys are helping each other out, and I hope with respect to this session I am able to help you out by teaching you many things, right? That's the reason we ask you to be a part of this particular channel. Again, or whatever you're taking away from here is free of cost, right? Ladies and gentlemen, you can find multiple places here at Great Learning Academy where you have access to really high quality free content on any domain, not just machine learning. We have Great Learning Academy, we have the Great Learning YouTube channel, and of course we have Great Learning blogs for people who love reading blogs as well. But then, now coming to the part we're going to be discussing about specialization in machine learning. Ladies and gentlemen, all these, everywhere around the world, if you take a look at it, all these free courses or anything else will give you a very good head start. It will take you from being a beginner to maybe an intermediate learner. But if you have to go from being an intermediate learner, or if you go from being a beginner to a thorough expert, well, that is where you're going to require a good amount of training, right? I highly suggest you guys take a look at these programs that we have here at Great Learning. This is the PG program, the post-graduation program in artificial intelligence and machine learning. This is an online course. This is an online PG program where you guys will be learning online for 12 months or 1 year. You can find out all the details about the career transition we've had, all the people who have joined which companies after they have completed this particular course. You can find all the details about the career support that you guys will get, all the jobs, recruitment drives, mock interviews, career mentorships, and so much more. And of course guys, with respect to this PG program, you're going to get 2 certificates. One is from the University of Texas at Austin. Look at that certificate, right? This will add so much value to your resume. And of course, not just one certificate, you'll be getting one more certificate from Great Lakes Executive Learning, wherein you guys can show it off on your LinkedIn profiles, on your resume. And you guys have to realize that if you have completed a post-graduation program and if you have a certificate from University of Texas at Austin for it, guys, you will know the amount of value it will add, right? The entire thing is basically designed to take you all from being complete beginners, complete newbies, all the way to being thorough experts. You will have access to 225 plus hours of learning content. You will be having a lot of quizzes, projects to work on, right? You can find out everything that you have to learn here. I'm just trying to show you guys all the syllabus, all the projects, AI, modules, time series analysis, right? I'm just scrolling down and it's just the names of those modules. If you click on those modules, you will see to what level of depth you guys will learn all of that, right? And of course at the end you'll have multiple hands-on projects, and you also have a capstone projects where you'll be working under the expertise of an industry expert, and eventually you guys can go on to work on your projects, right? Look at this. You will have access to so many projects from so many different domains. You can find out a lot about the faculties and the mentors. These guys are the leading academicians in the field of AI and ML, right? You can find out who are going to be your trainers. You can find out about your mentors. Apart from your faculty, you will have mentors as well, and of course you can find a lot of other details on this particular page, right? I'm sure the person handling the chat right now is going to give you a link to this particular program, right? You'll find out all the details about this, and since it's a post-graduation program, ladies and gentlemen, it comes with a fee as well, right? You can find out all the details about this. It's a 12-month program, 225 plus hours of online learning content, and a ton of other very important things needed for a learner, right? Well, there is an application process for this, guys, so make sure you're heading to this page. In fact, what you can do is actually head to this page, and in fact head to the bottom of the page, guys. When you go to the bottom of the page, you will see a part where you can give us your name, email ID, mobile number, and your work experience. As soon as you put all of this and hit submit, we will make sure that we will have someone from our admissions team give you a call and talk to you for free and eventually guide you about what it is that you want to do in your career, and to see if there are any programs here at Great Learning, I am sure there would be, to help you get to that particular goal, right? We have multiple programs in multiple domains, so how will you know which one to pick? Well, let our experts help you out, right? Just put down your name, put down your email, and if you guys are students or if you don't have any experiences, you of course you can select college student, you can select 0 years if you're graduated and you're looking for a job. This way our experts can help you better. Again, ladies and gentlemen, as soon as you put your details and hit submit, we'll have someone from our team give you a call, right? Again, you can ask all of these details, all of these queries for free, and you can understand what it is that you require exactly to advance in your career, right? Well, with that, ladies and gentlemen, we have come to the end of this particular live session. Thank you so much for watching. I see in the comment section that you guys are fantastic, right? As always, it is a pleasure to be teaching all of you all. You kept the comment section super interactive. I hope that we are clear with everything that we have learned on the agenda today, right? We understood why Python is so popular, why you have to learn Python, why Python for machine learning. We understood all the skills that you're going to require with respect to Python machine learning, and we understood supervised learning, unsupervised learning, reinforcement learning. And after all of these things, we also made sure to take a look at 2 demos using one common data set to see if we can have multiple different algorithms behave differently using the same programming language. Of course, it has to work, and as you saw, it worked fantastically well, right? Tiny amount of code, large amount of impact, easy to use programming language, top paid positions in the entire world is of a Python programmer's role, a data scientist or a machine learning engineer. So with this, I hope all of you all have the right expertise and the tools and techniques that you guys are going to need to take your learning ahead, right? Well guys, with this, again, thank you so much for watching. Make sure you guys are staying safe from the ongoing pandemic. Make sure you're getting your vaccination shots or maybe wearing your masks and trying to keep safe, right? On that note, guys, we're learning from home, we're all working from home, and as soon as the pandemic ends, and in fact the pandemic is not even ended right now, and you can see all these IT companies, all these trends are just going up and up and up, right? So right now would be the perfect time for all of you all to pick up technologies like this and learn. And of course, with that, you can take a look at Great Learning Academy and our Great Learning YouTube channel for more content such as this. All right guys, thank you so much for watching. My name is Anirudh Rao, and I'll see you on the next session. Have a beautiful day ahead. Thank you so much.